Hi friends, you should be on page 124 at this point, so go ahead and flip your page if you didn't already. And I want to talk through the reflection questions here. Remember that on the previous page we had that tortoise going 3.5 inches each second for 1 second. And so the question here says, suppose the tortoise travels for 12 seconds at the same rate. Explain how you could find the distance that tortoise travels. So go ahead and take a second to think about it. All right, now I'll share my thinking. So if you need to pause the video, go ahead and do that if you need some more time to solve it. But I'm going to share my thinking now. So if we use our unit rate, we can always start from our unit rate to find out anything. So if we go back to our unit rate of that 3.5 inches for 1 second, we just want to find out how long it takes for 12 seconds. And so I have to make an equivalent fraction. So what did I do to get from 1 second to 12 seconds? I multiply times 12. And so I'm going to do the same thing at the top. I'm going to multiply times 12. And 3.5 times 12, that's 10, that's 7, that's 0, that's 5, that's 3, 0, 12. I've got to move that decimal point in there. And so that's 42 inches per second. And so there's our answer. For that first one. Okay, so you're just making equivalent fractions. Explain why the tortoise's walking rate could be called a constant. Well, let's think about that for a second. It doesn't change. It's constantly going the same speed, no matter if it was 1 second, 12 seconds, an hour and a half. It doesn't matter. That didn't change. So this is considered proportional to each other. We're going to use both of those words. This is considered proportional, and it's considered constant because it does not change. It's constantly the same, okay? And so that's what you need for those two questions right there. Let me go ahead and erase this, what I came up with, and let me move the screen up so we can move on to the next part. I hope that you're making good choices and that you're behaving for the sub. I hope you're making her day a good one. Hope you're getting ready for a nice break. I'll miss you guys during that time. Hope you'll do like lots of math homework, right? Doubt it, but I can always hope, right? All right, so let's go down here for the proportional relationships. This is a lot of math talk, but I'm going to walk you through it really quickly just to ensure that we understand what we're talking about. A proportion is a statement that two rates or ratios are equivalent, okay? So if you're proportional, you're equal to each other. So 6 miles for 2 hours is the same thing as 3 miles for 1 hour, or 2/4 is the same thing as 1/2. So it's just equivalent to each other. That's all. A proportional relationship has to have at least two things. Between two quantities is one in which the ratio of one quantity to the other is constant, so it doesn't change. Okay, so if it's a proportional relationship, just like that problem we did above with the 3.5 inches per 1 second, and then it was 42 inches for 12 seconds, that was constant. It didn't change. It was a proportional relationship. And so a rate of change is the rate that describes how one quantity changes in relation to the other quantity. So in a proportional relationship, the rate of change is constant. So it went, for the problem above, for every second, 3.5 seconds. That was the rate of change, was 3.5 inches for every 1 second, okay? A proportional relationships are described using words such as per or for each. That's how you know what is going to be in the numerator versus the denominator. Remember we said that the, you guys, I forget the name of that. You guys probably remember. You remember you looked it up on like the second day of school? This thing, you guys know the name of it. I can't think of it right now. But that division line right there, remember we said it stands for per, right? Or for each in this case. That'll help you know what's in the numerator and what is in the denominator. So if we say $1.25 per pound, we know that we have the numerator is the $1.25, and then the per stands for that line right there that you guys remember and I don't, and then we have the denominator. Okay, so let's talk as an example down here. Let me erase what I've got going. All right, so it says Callie earns money by dog sitting. based on the table, is the relationship proportional? Between the amount Callie earns and the number of days, a proportional relationship. Okay, so let's see. I'm looking at if she babysits or she dog sits for 1 day, then she earns $16. And for 2 days, she earns $32. And so if you see the math down here, I'm saying that she earns $16 for 1 day. And I've got to find out if that is equivalent or proportional. Equivalent and proportional mean the same thing, to $32 for 2 days. And so if I simplify this, I can divide by 2, and that equals $16 per 1 day. So these two are equivalent and proportional. But in order to see if the relationship is the same throughout, I've got to check all of these. Okay, so just like the problem did, they checked 48 over 3 days. They simplified that by dividing both by 3 to get it down to the unit rate, and it was $16 for 1 day. The same thing with $64 for 4 days. You simplify that, you get $16. Same thing for $80 over 5 days. You simplify that, you get $16. So each rate is equal to that. She gets $16 per day. It never changes. It's a constant. And so it's a proportional relationship. That's how you check them. You make a fraction out of these guys. Okay? Make a ratio out of them, I should say. You make a ratio, you simplify that ratio, and then if they're all the same, then you have a proportional relationship. If she ended up getting a tip 1 day, or if she gave them a discount and they had a coupon 1 day, then it would not be a proportional relationship because one of those days or a couple of those days would be different than the others. And so if they are all equivalent fractions or all equivalent ratios and they're constant, then you have a proportional relationship.